Greetings, math fans. All right, so this is the next day of limits. Okay, so we're doing a lot of stuff with limits here, but today's limits are going to be involving infinity. All right, and so we're going to approach infinity. Now, infinity is not a number. You can approach infinity. You can't get there. I've been there like 2 or 3 times. Most people have never been there, and I got a buddy of mine. He's been like beyond it. You might know him, Buzz Lightyear. Um, but for most of us, you can only approach infinity. All right. So let's just title it here: limits involving infinity. You guys need to practice drawing infinity. It's pretty easy. Just a sideways 8. Okay, turn your notebooks or iPads sideways and draw an 8, and then you're good to go. So when we talk about limits involving infinity, we're talking about end behavior. In other words, what's going on? We're going to infinity. What's going on when I make x really, really, really big? I want to know what's going on to the y value. Okay, so real quickly, just to kind of give you a little demo here, if I ask you y equal, or give you an equation y equals x, what happens to y when x gets really big? So when x gets big. Well, the answer, I mean, think about it. As x gets really, really, really big, doesn't y get big too? So y gets big. So I would say limit as x approaches infinity of the function, it's x, right? That's our function, is equal to, in other words, I'm telling you x is getting big, and this is saying what's y? Well, y is getting big too, so y is going to infinity. Okay? If I gave you a problem like this, y equals 1 over x, and again, x gets big, what happens to y? Well, think about it. 1 over 10, 1 over 1,000, 1 over a billion, 1 over a trillion. What does it go to? It goes to 0, doesn't it? The value of y, 1 over a billion, 1 over a trillion, 1 over a quadrillion. It gets really, 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 really small. So when x gets big, y approaches 0. So you would say limit as x approaches 0 of 1 over x equals 0. And think logically, right? As x gets, it's infinity. As x approaches infinity, it's getting, the bottom's getting bigger and bigger and bigger, and then the whole thing is 1 over something is going closer and closer and closer and closer to 0. Okay? So I'm going to keep some of these up here because we're going to actually use these. I'm not going to erase them so you guys can actually, look back at this. So let's take a look at another one here, math fans. If I said, we're going to call this 1, I'm going to label this 1, and then our second one here, if I said limit as x approaches infinity of 2x squared plus 5x minus 3 over 3x squared minus 2x plus 8. I want you to kind of think here, as x gets really, 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 really big, this doesn't really matter, does it? I mean, when x is a billion, and if you subtract 3 or add 8, it doesn't even do anything to the problem, right? It just doesn't do anything. In fact, this doesn't do anything either because if I square, let's say if I have 10, right, and then I square it, it's 100. Okay, it's a lot bigger. If I have 1,000, I square 1,000, I get a million, right? 1,000 thousands is a million. So in other words, as x gets really big, nothing matters except for the highest degree, the top and the bottom. Okay? Everything else is kind of basically it's irrelevant. Okay? So basically a general rule, no saluting required. A general rule is you keep the highest degree for both the top and bottom of a rational function. then simplify, then evaluate the limit. So again, this stuff is out of here, right? And truly, I have this limit as x approaches infinity of 2x squared over 3x squared. Now you simplify that, and of course, what does that simplify to? Well, the x squared's canceled. Don't I get 2/3? And then I evaluate the limit. Now, this is a constant here. It's 2/3. So the limit is at x approaches infinity. There's no x there anymore. So what's the answer to this? 2/3. Okay? So, follow that general rule, and you're going to be good to go here. We're going to actually do several problems where the degree is bigger on top, degree is bigger on the bottom, the degree is the same. In this case here, the degree was the same on the top and the bottom. Okay, we're going to kind of pull some stuff together that we learned in Algebra 2 as well, what we're doing with limits and end behavior. Okay, let's keep going here. Let's do number 3. Limit as x approaches infinity of 5x squared plus 7x minus 3 over 2x minus 7. Okay, so remember what I told you guys to do? We can pretty much eliminate this and this. We just keep the highest degree on the top and the bottom. So it's limit as x approaches infinity of 5x squared over 2x, right? Now we simplify it, so that's going to give us limit as x approaches infinity of 5x over 2. And now think about what happens when x gets really, really, really big. Doesn't the whole thing go to infinity? Yep. Because 5 billion, 5 trillion, 5 quadrillion over 2 is infinity. Okay? All right. That's pretty good. Number 4. Limit as x approaches infinity of 3x squared minus 7x over 4x cubed minus 6x minus 7. So again, I'm going to keep the degree on top, the highest degree on top, so you get limit x approaches infinity of 3x squared over 4x cubed, right? Everything else is out of there. And so if I simplify that, limit as x approaches infinity, I get 3 over 4x. So this is similar to that problem, the 1 over x. What happens when x gets really big? That whole thing goes to 0. Okay, and then the last one here, limit as x approaches infinity of negative 5x squared minus x over 2x plus 3. We'll get limit as x approaches infinity of negative 5x squared over 2x. So it cancels. Limit as x approaches infinity. Cancel, we get negative 5x over 2. So what happens when x goes to infinity for this one? Well, doesn't it go to negative infinity? Sure it does. Negative infinity. Okay? So I kind of numbered all these because I wanted you to think a little bit about, first of all, the title of this whole thing here is end behavior. Limit to infinity, which is important, and end behavior. If I asked you, and this is even from day 1, and also from your Algebra 2 class, if I asked you to graph a rational function like 3x, like number 4, for example, let's take a look at that. If I asked you to graph that, you would come up with a vertical asymptote by setting the bottom equal to 0, and then you'd come up with a horizontal asymptote, right? And how would you come up with the horizontal asymptote? Wouldn't you actually look at the degree at the top and the bottom? You remember that? So if the degree is bigger on top, do you remember those are oblique asymptotes? It's a good word to know, okay? And if the degree is bigger on the bottom, it's automatically y equals 0. So interestingly enough, if I look at this, so looking at number 4, the degree is bigger on the bottom, right? That's bigger on the bottom, so it's the limit is equal to 0. So truly, the horizontal, if I want to write a horizontal asymptote for this, it's y equals 0. That's end behavior, guys. When you're following that asymptote, all the way to the end. I want to know what's going on as I'm getting closer and closer to that asymptote. As I go farther and farther out to infinity, what am I approaching? What y value am I approaching? X value, I'm going to infinity. Y value, what am I approaching? You approach the asymptote. Just like number 2 here, right? Remember, the degree is the same. So you actually keep the coefficients of those numbers here, right here. So I keep those coefficients, and that's why my horizontal asymptote is, HA, is y equals 2/3. And number 3 and number 5, it's going to negative infinity and positive infinity because they don't have horizontal asymptotes. These are oblique asymptotes. Same thing with this one, oblique asymptote. Okay? Because it's the degree is bigger on top. So it's going to go up at a linear, actually, linear up or linear down, depending on if it's positive or negative. Okay? So that's what end behavior is all about. It's looking at the asymptotes, but you find this based on limits. So if I can put like just a general rule down here, just to kind of write this out, end behavior are basically horizontal asymptotes. Sounds like I'm swearing, but we know what we're talking about here, horizontal donkey purses, right? But they are limits to infinity and beyond. No, just to infinity and negative infinity. So I'm going to tell you y equals b is a horizontal asymptote of a graph of a function y equals f of x if either the limit as x approaches infinity of f of x equals b, or the limit as x approaches negative infinity of f of x equals b. So what I'm trying to tell you here is, if you find the limit, if you find this limit and it's equal to some value b, some constant value, not a variable, but some value b, then that horizontal asymptote is going to be y equals b, which is what we figured out, right? Like number 4 and number 2, right? Horizontal asymptote was that value when you went to the limit to infinity or to negative infinity. Okay? So that's kind of what end behavior is all about. It's limits to infinity, limits to negative infinity. So, and those are for rational functions. So let's actually, I want to talk a little bit about one more thing here. Can I cross a horizontal asymptote? Can I cross it? Cross. Yes, you can. Okay, you guys learned that. I mean, here, if I have a horizontal asymptote here, it still approaches it, but it might go like this and then come back around. Okay, so I definitely can cross it. How about a vertical asymptote? Can I cross that? No, because a vertical asymptote would be like 1 over, x minus 2. I have a vertical asymptote at 2. Certainly can't cross that, because if you crossed it, if you actually touched it, it would be undefined. So, no, cannot cross a vertical asymptote. Okay? All right, so let's look at some other limits involving infinity, because some of them can be a little tricky. You're going to have to think about graphs. You're going to have to think logically what happens when a numerator or a denominator get bigger and smaller. Actually get bigger. Okay? So let's clear all this out of here now. And if I said limit as x approaches infinity, and let's do sine of x over x. Do you guys remember that one? That was your little advanced pre-calc question. Okay, you guys had it on a test a couple of chapters ago. So if you guys can remember, what's going on with the top? Well, the top, it's sine of x. Sine goes from between -1 and +1, right? It's fluctuating between -1 and +1. And what's happening to the bottom? Well, the bottom is getting enormous. So I don't care if the top is fluctuating between -1 and +1. If the bottom's getting huge, it's going -1 billion, +1 trillion, -1 quadrillion, +1 quintillion. Okay, it's getting closer and closer and closer to 0. So that's what this is. So limit as x approaches infinity of sine of x over x is 0. And then just think logically about it. Oh, sine's fluctuating between -1 and 1. Bottom's getting bigger. Okay? Very, very important. So if that equals 0, I would have a horizontal asymptote, which I'm going to ask you in your homework. It's going to be y equals 0. Make sure you give me the y equals. Don't tell me 0. The limit is equal to 0, but the horizontal asymptote is y equals 0. Okay, so let's look at a few more. Limit as x approaches infinity of cosine of 1 over x. So again, think logically. When x gets smaller, or x gets bigger and bigger and bigger, 1 over x is smaller and smaller and smaller. So what is this going to? Well, isn't that going to 0? And what's cosine of 0? 1. Okay, that's the way you have to kind of think about it. You got to think, well, what's going on with that function when x gets really big? Oh, it's getting 1 over that is getting small. Cosine of something really small is the same thing as saying cosine of 0, which is 1. Okay, so let's keep going here. Got a bunch more to do with you guys. Limit as x approaches infinity of 5 minus x over x plus 1. And you're like, whoa, that's kind of got a lot of stuff to it. I'm not sure how to handle this one. But if you guys remember the sum rule or sum rule for limits, you can split that up. So I have limit, actually this is difference rule because it's subtraction, but limit as x approaches infinity of 5 minus limit as x approaches infinity of x over x plus 1. So that one's easy. That one's just 5. I don't care what its limit's going to. If it's a 5 there, just a constant, it's just that value. Okay, and then you have limit as x approaches infinity. Well, remember, if the degree is the same on the top and the bottom, okay, if its degree is the same on top and the bottom, then you just look at the coefficients. So again, I'm ignoring that 1, and x over x is 1, so minus 1. So my answer is 4. So my horizontal asymptote is y equals 4. Sweet. Sweet. Okay, not bad. Let's do a little crazier one here. Limit as x approaches infinity of 7 minus 2x over x plus 1 times parentheses, oh man, this is crazy. You guys are going to want to drop, but it's too late. X squared over x cubed minus 2x plus 6x to the 4th plus 4x squared over 3x to the 4th plus 2x cubed. Woo! That's a humdinger. Okay, so that's really the limit of that whole thing. And I would just split up and do each one separately. Okay, now remember this is multiplication here, but no big deal. So I'm going to say limit, well, as opposed to here, I'll do it in red here. What is this limit? Isn't it just 7? And it's minus, and what's this limit? Well, aren't these degrees the same? So it's just 2 over 1, so it's 2. So that's the first one. And then what's this limit? Well, isn't the degree bigger on the bottom? So it's automatically y equals 0, so it's 0. And what's the limit of this one? Well, these are out of here, right? And you keep these highest ones here. They're the same degree, so they cancel, and you get 6 over 3, which is 2. So I end up getting 5 times 2, which is 10. Okay, so my horizontal asymptote is y equals 10. All right. Sweet. Here's a good one. I like this one. Limit as x approaches infinity of absolute value of x over x. you guys should remember how to draw that. Okay, that means you go at 0, you're out that way, and you're out that way. And remember, there's a hole. It's undefined at 0, but it only is going to be positive 1 or negative 1. So what happens? The limit as x approaches infinity is what? So we're obviously going out to infinity. And what is the y value? You're always thinking about that. What is the y value? Which means, what is that? Because that is y. If I said it's y is equal to absolute value of x over x. So what is the y value when x gets really, 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 really big? Well, isn't it constant? It's getting closer and closer. In fact, it is at 1. So the answer for this one is 1. Okay. What about limit as x approaches negative infinity? Well, which way? What's the y value approaching? Negative 1. Okay. So again, think about the graph. All right, let's do another one here. Limit as x approaches infinity of absolute value of x minus 2 over x minus 2. Well, it's actually not that bad, right? If I go out to 2, don't you guys agree it's the same look? So actually, what's the answer to this? As x goes to infinity, it's not approaching 2. Don't tell me that. 2 is right here. That's x equals 2. What's the value of y? Well, the value of y is at 1. So it's also 1. So again, I would say a horizontal asymptote is y equals 1. Okay? Not bad. How about limit as x approaches infinity of 105? You guys should know that, right? Doesn't matter, it's a constant, so it's going to be 105. So, once again, I have a horizontal asymptote at y equals 105. Love 105. Okay, so here I got a couple other tricky ones for you here. And again, just think logically. Don't memorize stuff. Okay, limit as x approaches infinity of x over sine of x. Okay, well, this one's a little different now. Do you guys agree? We did sine of x over x, and this is so this is going between negative 1 and 1, and this is getting bigger. So what's going on is if that top is getting bigger and bigger and bigger, but that's fluctuating between negative 1 and 1, it's like a positive big number, then a negative big number. Positive big number, right? As this fluctuates between 1 and negative 1, 1 and negative 1, 1 and negative 1, and this gets bigger and bigger and bigger and bigger and bigger, it's going to fluctuate between positive, negative, bigger numbers. So like, it'll be 10 and negative 50 and positive 100 and negative 1,000 and positive 1 million. So it's going back and forth and back and forth. If that's the case, guys, this limit does not exist because it's not going anywhere. Okay? It's not like going to a 0 or it's not going to infinity. I can't say it goes to infinity because it's getting bigger, but bigger positive, then bigger negative, then bigger positive, bigger negative. So it does not exist. Really important to kind of recognize that. Okay? And also one thing I did want to mention too, let's go back to this problem, the one we did already. Limit as x approaches infinity of sine of x over x. You know where kids get confused by this one? Is this. We learned this a couple days ago. Limit as x approaches 0 sine of x over x. Guys, please don't get these confused. This one's going to infinity, so that's going to 0. This one's going to 0, it's going to 1. Okay? So just think logically. If you plug a 0 into here, well, it's undefined. Oh, that's the one we learned. That's a special case, so that's equal to 1. This one, I can't really plug an infinity in there, but it's getting bigger and bigger and bigger on the bottom. And again, sine of x is going between negative 1 and 1, means the whole thing is going to 0. Okay? And this is not D and E. People sometimes mess that up too. Because you're doing like, positive 100 or 1/10, negative 1 over 100, positive 1 over 1,000, negative 1 over 10,000. And what's going on is it's getting closer and closer to 0. It just happens to be positive, negative, but it's still getting closer and closer to 0. Okay? So that is a pretty important problem. And let's do this last one here. Limit as x approaches infinity of 2 to the negative x. This is actually a little confusing if you just kind of look at it, because you're like, what happens if you go to infinity? I would rewrite this. Okay, so if you have negative exponents, I would rewrite with positive exponents. Then evaluate the limit. I think it's easier. So watch this. Because I don't know, sometimes people get confused. They're like, oh, I don't know, negative x, I don't know what to do here. So if I do limit as x approaches infinity of 1 over 2 to the x, right? Remember, you have a negative exponent, you move to the other side of the fraction. So if it's on the bottom and it was negative, you move it to the top. Just be careful about that. So what happens when x goes to infinity now? 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the millionth, 2 to the trillionth. Doesn't this get really huge? And then what happens to the whole thing? It gets really small. And if it gets so small, we can say limit as x approaches infinity of 2 to the negative x, then of course is 0, because it's getting really, really, really small. Okay? So again, if you have negative exponents, rewrite it with positive exponents, and then evaluate the limit, and I think your life is going to be a lot easier if you do all that. Okay? So that's it, math fans. Again, be careful about the sign of x over x, whether it's going to 0 or infinity, because that actually can cause you some grief. You know, understand about the degree. I'd like to summarize this because I will in class. As far as rational functions. So if you have the degree is basically, we'll do the 3 different scenarios here. Degree bigger on the bottom. You know, like x squared over x cubed. The horizontal asymptote is going to be automatically y equals 0. If the degree is the same on top and bottom, you know, like 5x squared over, 3x squared, the horizontal asymptote is going to be y equals, in this case here, 5/3, right? It's going to be the coefficients. Okay? And then if the degree is bigger on top, like x cubed over x, then if I do the limit, it's going to go, well, if I simplify it, it's just x, right? And there is no horizontal asymptote because it's oblique. There's nothing horizontal about it. It's oblique. It's going to go up as an angle here, right, with a slope. And so if the degree is bigger on top, the limit's going to go to infinity or negative infinity. And again, there's no horizontal asymptote. Okay? So just kind of a quick review. And that's it. Limits to infinity. All right? So we actually have a lot of problems that just talk about, they ask you for the limits, and they also ask you for the horizontal asymptote. So to make sure you guys give me a, an equation when, when asked for an asymptote, a horizontal asymptote, and don't just give me a number. Okay? So, and I also, for a lot of these, I ask you guys to find the limits going to positive infinity and negative infinity. So just make sure, you know what's going on here. Like, let's just kind of look at this guy right here, this guy. If I said going to negative infinity, it's still going to 0, right? And if I said this one's going to negative infinity, it's still going to 5/3. The only thing that really changes, what happens if it goes to negative infinity here? Well, that means that goes to negative, the whole thing goes to negative infinity. That's all. So it only changes when the degree is bigger on top, when it goes to positive infinity or negative, a positive or negative value. Okay? So that's it, math fans. Have an outstanding day. Adios. Goodbye.